Hello everyone, this video is about energy, work and power. Gravitational potential energy or PE equals mgh. Kinetic energy or KE equals 1/2 mv squared. Delta KE, the difference in KE we subtract. So remember to square first and then subtract, not the other way around. Work done by a force W equals F times S. The work done by friction force is heat or thermal energy. Power P equals work divided by time or force times velocity. We have two possible scenarios. When the velocity is constant or sigma F equals 0, the engine or the applied force equals the resistance or friction force, and therefore the power is engine force times velocity or friction force times velocity. Or if we have acceleration, sigma F equals ma, the engine force minus resistance force equals ma, the instantaneous velocity is v, the power at that instant is the engine force times the velocity. And make sure you know what the letters represent. Conservation of mechanical energy. The sum of potential and kinetic energy of an object remains constant if air resistance or friction or thermal or heat energy loss is not ignored. So mechanical energy before, mechanical energy after, potential plus kinetic, mgh 1/2 mv squared, mgh 1/2 mv squared must be constant. For example, 7 kg box released from rest from a height of 20 meters. So when the height is 20 meters, this is when the box is just released, the velocity is 0. The potential energy mgh, the height is 20. The ke, velocity is 0, ke is 0. So the total energy or the mechanical energy is 1400 joules. Let's use m, so not to be confused with heat or thermal energy. And the mechanical energy is always 1400. So let's say if we know the velocity is 10 meters per second, we can find the kinetic energy 1/2 mv squared, we get 350, and if we subtract, we get the potential energy. And if we know the potential energy, we can use mgh. The height is of course the potential energy divided by mg, and we get the height. Or we can also use Sufat here. We know the initial energy velocity is 0. This is v squared equals u squared plus 2as. The v is 10, the u is 0, the a is 10. We can find the h using Sufat, also 15. Let's say we know the potential energy this time. We can find the kinetic energy 1400 minus 896. And if we know the kinetic energy, we can find the velocity using the square root of kinetic energy divided by 1/2 m. We get the velocity using energy equation. Or we can use Sufat if we find the height first. If we know the PE, we can find the height. PE divided by mg, we get the height. And if we have the height, we can find this is the height from the ground, which means the distance fallen is 20 minus this, which is 7.2. So if you want to use Sufat, we have to use the distance fallen, which is 7.2. We get velocity equals 12 as well here. And let's say we have the kinetic energy this time, so the potential is 504. We can find the velocity if we know kinetic energy, ke divided by 1/2 m square root of or we can find the from potential energy we find the height first, and from the height we can find the velocity, or if we know the velocity we can use Sufat to find the height. So this 7.2 is from the ground, but if we want to use Sufat, this is v, this is u, this is the h will be the distance fallen. So from here you will get 12.8, but if you know the distance fallen, you can just subtract 20 minus 12.8, you get the height from the ground. Energy method, remember each term must be positive, so you have to do the bigger minus a smaller value, and the initial energy equals final energy. For delta KE, kinetic energy, if the speed decreases or slowing down, we put it in the initial energy side. If the speed increases, it's gaining kinetic energy, we put it in the final energy side. So we have two sides of an equation. We have to put the delta PE on the left, or on the initial energy side, if the height decreases, because we are losing potential energy, and on the final energy side if the height increases. Thermal energy is always on the final energy side, because it's always the result of friction or resistance force, so it's never there in the beginning, it's there in the end always. Work done by a force such as engine force or applied force must be on the initial side. For example, a car moving uphill, engine force, resistance force, initial speed, final speed, distance, inclination angle. So if this distance traveled on the slope is d, the height traveled upwards, the height upwards should be d sine a, using a sine definition. So because the speed is decreasing, initially we have delta ke. So on the input side, or the initial side, we have delta ke, and since we have the engine force, we have w on the left as well, and the result is we are going higher, so we have a potential energy gained, and we also have thermal energy because of the friction. So the calculation should be 20 squared minus 10 squared. It's got to be positive, so it's not 10 squared minus 20 squared. And for the work done by the engine force times the distance on the slope. For the potential energy, we have to use height, so it's vertical height, we have to use d sine a. And for the thermal energy, heat because of the friction or resistance force, we use the resistance force or friction force times the distance on the slope. That's it. I'll see you again next time.